This video is on applications involving parabolas. So this first example we have here, we got Rose tosses a ball upward from the top of a 160-foot building. The height of the ball above the ground in feet at any time t, which is in seconds, is given by this function h of t equals negative 16t squared plus 80t plus 160. It says round your answers to the nearest tenth. So first off, let's make sure we understand the function. You're going to put in the time in seconds, right, for t, and h of t, the height at that time, will be in feet, right? So it's important to know that. The other thing important to recognize that when you say h of t equals this negative 16t squared plus 80t plus 160, that t squared, that squared being the highest power, tells you it's a quadratic equation, and it being squared tells you it's a parabola in terms of shape. The negative in front tells you it's going to be a upside down parabola, right? And that's going to be important because what we're going to do is we're going to talk about things like at what time will the ball reach its maximum height. Well, what's really happening here is that this parabola, right, if it's upside down, that tells you the maximum is at the vertex. So when you're at the vertex, right, that's how you know you're at the maximum. In other words, if the parabola is upside down, you're going to have a maximum at the vertex. If the parabola was right side up, right, you would have a minimum at the vertex. So most of these problems we're going to talk about are going to involve maximum and minimum in some way. So it says at what time will the ball reach its maximum height? So we're looking for what time. So we're looking for the t value of the vertex. So t is equal to, remember to find the t value or the x value in most cases of the vertex, right? Remember it's equal to negative b over 2a. And so we're looking at negative, remember this is A, B, and C, so negative B would be negative 80, right, the middle coefficient. So negative 80 over 2 times A is 2 times negative 16. Remember A is the leading coefficient. So I end up with negative 80 over negative 32. A negative over a negative we know is going to make this a positive. 80 divided by 32. We end up with 2.5. Remember we said round to the nearest tenth. In this case it comes out that way. So 2.5, this is what? Time. So time was measured in seconds. So at 2.5 seconds, right, the ball reaches maximum height. It's where the vertex occurs. It occurs at a time and then a height at that time. Alright, so then the next question is, what is the maximum height of the ball? Well, what's the height at 2.5 seconds? Well, that's h of 2.5. So it's the height at the vertex, right? So the height at the time of 2.5, and you substitute in. So it would be equal to negative 16 times 2.5 squared plus 80 times 2.5 plus 160. And we'll simplify this. You know, make sure you're following your order of operations. You got to do the 2.5 squared first. And that gives me 6.25. So we got negative 16 times 6.25 plus 80 times 2.5 at 200. So plus 200 plus 160. And if we multiply this out, negative 16, don't lose that negative, times 6.25 plus we have 200 plus 160, so plus 200 plus 160 gives us 260, and this is 260 what? Well, it's 260, the maximum height of the ball is in feet, right, because we're looking for height, right? So at 2.5 seconds, the height at 2.5 seconds is 260 feet. So the maximum height occurs, right, after 2.5 seconds at 260 feet. That's going to be the height of the parabola at the vertex. The next question is, when does the ball hit the ground? Well, what's the height when the ball hits the ground, right? So when means we're looking for a time. So you're going to try to solve for t here. When it hits the ground, what's the height? Well, the height is 0. So we're really going to set h of t equal to 0. So we have 0 equals negative 16t squared plus 80t plus 160. We want to solve this. We can try to solve it by factoring first, if we can. So we can factor out a negative 16 here. We end up with a positive t squared. 80t is positive divided by negative means it's a negative 80 factoring out the 16 leaves with 5t. And then the positive 160 to taking out or factoring out negative 16 makes us a negative 10. Now if this factors further, you factor further. T squared minus 5t minus 10. Since we have, three terms, you don't see a value in front of our t squared, you try to find numbers that multiply to 10 that add to, or multiply to negative 10 that add to negative 5. We don't have any numbers that do that. So what's another way to solve this? Well, another way to solve this is using the quadratic formula. So I'm going to use the quadratic formula here. Just on the inside. You could do it on the original problem, still get the same answer, but it's easier to work with the smaller numbers. So remember, it's t equals, or x equals was x in here, but in this case t equals. And then remember, it's negative b, so it's negative, what's b? Now remember, we're using this inside part. Well, b is negative 5, the middle coefficient, so it's negative 5 plus or minus the square root of, alright, we got b squared, b is negative 5, so negative 5 squared, minus 4 times a is 1 in this case, remember the coefficient of t squared, and c, which is the the constant term at the end, which is negative 10. And this is all over, remember, 2 times a, which is 1. Alright, so I'm not going to reteach the quadratic formula. You should know how to use that from our previous sections. So we end up with t equals, simplifying this, a negative times a negative makes us a positive 5, so it's positive 5 plus or minus, let's simplify the inside of this. We can do it all at once. A negative 5 squared is going to be 25, positive, right? It's positive 25. Negative 4 times 1 times negative 10 is going to be a positive 40, so we have 25 plus 40. This is going to be the square root of 65 all over 2. And since we're approximating, we know that square root of 65 isn't a perfect square. If we left this in exact form, you'd have to keep the square roots in here. Because we're approximating to the nearest tenth, I'm going to round this using my calculator. So 5 plus or minus, get the approximation, the square root of 65. We have 8.06, and I'm going to use 2 decimal places for now until the end, and then I'll round it down to the nearest tenth, meaning 1 place. So we have 5 plus or minus 8.06 divided by 2. How many answers is this? Well, it's 2 answers, right? It's 5 plus 8.06 divided by 2, and it's 5 minus 8.06 divided by 2. So 5 plus 8.06 is going to be, I'll just do it, I'll just say it's going to be 13, but 5 plus 8.06, so it's 13.06 divided by 2. I end up with 6.53. Since they said around the nearest tenth means 1 decimal place, so we have 6.5. Here, 5 minus 8.06 is a negative 3.06 divided by 2. A negative over a positive is make this negative. Now, what's important about this is what we're trying to find. We're trying to find time, when, right? When does the ball hit the ground? Well, this is at 6.5 seconds, right? A negative answer, though, what do we do with that? Well, we can reject it because time can't be negative, right? That's why we're rejecting it. So when does the ball hit the ground? At 6.5 seconds. Now, if you're not sure what was going on here, and it might not be obvious to you, one of the things you can notice is that this is actually, if you're looking at this, let me just do a quick sketch of what this curve would look like. All right, so we've got this building, right, and here's the ground, and so she's tossing the ball off the top of the building, right? So the ball is getting tossed off the top of the building, and it does something like this, right? That's what happens. She throws it up in the air, and then it comes down, and it's following the shape of a parabola, right? And we know the vertex, right, here is at, remember, this is going to be a time, right? So the time is at 2.5 seconds. The height here, right, if you're thinking of this as an axis, right, at 2.5 seconds, right, this is time. Well, what's the height here? Well, the height was 260 feet. Now, how high up does she start? She was at 160 feet, so this would be at 160 feet. The ball hits the ground, right? The height here is 0 feet. So it's really a parabola that's coming down like this. When does it hit the ground here? Well, that's what we just found, the 6.5 seconds. So it hits the ground at 6.5 seconds. And what about this other value that we got? This would have been negative, what? It'd be 3.06 divided by 2. It'd be something like negative 1.5. Well, that would be back here. And that's how the parabola works. But this whole part doesn't matter because she can't go back in time, right? She can't do it before it happens. So that's why we're only doing this part of the parabola. So just to give you an idea of how this parabola is modeling what's going on here. Now, in this case that we just did, the x-axis or the t-axis was time. In the next example, the x-axis, the horizontal axis here, this will actually be distance, and we'll talk about that. So hopefully that first example was okay. Let's take a look at the second one. So it says a ball is launched in the air and has the function f of x, modeling height in feet. All right, so f of x is height in feet as a function of the horizontal distance x as follows. So x is the horizontal distance. F of x, or the y value, is the height in feet. Alright, so it's the vertical distance, is another way of saying that. We have f of x equals negative 0.04x squared plus 2.1x plus 6.1. So it says find the maximum height of the ball to the nearest tenth of a foot and the horizontal distance at which this occurs. Now, keeping in mind that when we talk about this, the horizontal distance is like your x value. The maximum height is like your y value, or your f of x. So in order to get the maximum height, the first thing you have to do is find the horizontal distance. Even though they ask you about it second, you need that first. You should notice that this is the equation of a parabola. Right, the highest power here is 2. A negative in front tells you that it opens downward. So we know we have a maximum at the vertex. So it says to find the maximum here, and they're giving you a parabola. You know you're trying to find the vertex. So the horizontal distance is the x value, so we need to start with that, because you need the x value of the vertex where you can find the y value. Remember, that's equal to negative b over 2a. When I say x equals negative b over 2a, in this case, what's b? Well, b is 2.1, so it's negative 2.1, right, the middle coefficient, over 2 times a. A is negative 0.04. And this ends up being negative 2.1 over negative 0.08. A negative over a negative makes it a positive. 2.1 divided by 0.08. I get 26.25 feet. So this equals 26.25. And I say feet because x is now measured, right, as a horizontal distance. It's not time, like in the previous example. It's a horizontal distance, so it's 26.25 feet. So the x value of the vertex is at 26.25 feet. That's the horizontal distance, right? That's what they're asking about here. We want the maximum height, though. The maximum height is the y value. So you want f of this x value, so f of 26.25. Which means you're going to be subbing it into this formula. So you have negative 0.04 times 26.25 squared plus 2.1 times 26.25 plus 6.1. And I'll do this on the calculator. Now, if you have a calculator that displays everything on the screen, once you write this, you could just type this in exactly as you see it. Make sure you have parentheses where I do. If you don't have things that, or don't have a calculator that displays it all on the screen, you want to, perform order of operations. So square that first, then multiply, and then add them. So I'll do it as one step. So negative 0.04 times, we have 26.25 squared plus 2.1 times 26.25 plus 6.1. And I got 33.6625. We'll round it to the nearest tenth, so that comes out to 33.7 feet. Remember, that's because that's the f of x, right? F of this, right? F of this height gives us this height as the y height, right? The maximum height, the vertical height, if you want to think that way. So, right, that's where the maximum occurs. What will the horizontal distance be when the ball hits the ground? So what is the horizontal distance? Horizontal distance, again, is the x value when the ball hits the ground. So when the height is, right, 0. So it's saying when f of x equals 0, when the height equals 0. So we're looking for the x value. We're going to sub 0 in for the y value, this side, the f of x side. So you have 0 equals, we've got negative 0.04x squared plus 2.1x plus 6.1. And then, you know, not too easy to factor with these decimals in here, even if it did factor. So we'll try using quadratic formula. Remember, it's x equals negative b, so it's negative, and then b is 2.1. Right, because it's the middle coefficient, plus or minus the square root of b squared, so it's 2.1 squared minus 4 times a. A is the negative 0.04, right, the leading coefficient, times c, which is 6.1. Make sure you take the signs with these, all over 2 times a, which is negative 0.04. And we'll simplify this. All right, so simplifying this here, I have x equals negative 2.1 plus or minus the square root of 2.1 squared is 4.41. And then a negative times a negative will make this a positive times a positive stays positive. So 4.41 plus multiplying 4 times 0.04 times 6.1, we get 0.976, this will be plus 0.976, all over 2 times negative 0.04, which is negative 0.08. And we'll simplify this to negative 2.1 plus or minus the square root of, we got 0.976 plus the 4.41 gives us 5.386 all over negative 0.08. And then we'll take the square root of that to simplify this. So we have negative 2.1 plus or minus the square root of 5.386, which is 2.32 over negative 0.08. And then recognizing that this is two answers. All right, this is negative 2.1 plus 2.32 divided by negative 0.08. This is negative 2.1 minus 2.32 over negative 0.08. Now, thinking about what happens here, negative 2.1 plus 2.32, this is a smaller number than 2.32, so the numerator will be positive divided by a negative. This is going to equal a negative. Now, if you're not sure, right, you can do it, negative 2.1 plus 2.32, and you get 0.22, which is positive, divided by negative 0.08, comes out to a negative. So it came out to negative 2.75 if you wanted to write it all out. But the important thing is it came out negative. If it comes out negative, remember, we're going to reject this because we're talking about a distance. You can't have negative distance. Here, a negative 2.1 minus 2.32, well, that's going to be negative, right? So negative 2.1 minus 2.32 is, oh, I typed it in wrong. Negative 2.1 minus 2.32. We get negative 4.42. We're going to divide that by a negative 0.08. This answer should come out positive, and it does. We got 55.25, which I'll round to the nearest tenth, so I'll say 55.3. And what are we finding? Well, this is the horizontal distance, so this is feet. So it's the horizontal distance when the ball hits the ground. All right. And then the last thing is what was the height the ball was initially launched from? So when you initially launch the ball, the horizontal distance the ball goes is 0. So it's saying when x equals 0, what's the y value? In other words, we're talking about the y-intercept. Right? This is when x equals 0. Right? So we're looking at the y-intercept. So if I was to draw a little sketch of this, just to give you an idea, right, it would look something like, okay, here's an x and y axis. Right, we have some sort of parabola that we know is upside down that looks like this. We know that, you know, the maximum height, right, we found this, the horizontal distance was at 26.25 feet. The height at that was 33.7 feet. And we know that when does it hit the ground? Well, it hits the ground here, which we just found was at 55.3 feet. And so what we really need is to figure out this height here, which is really the y-intercept in this part of the question. So when x equals 0, all you're doing is subbing 0 in for x. So f of 0 is another way of saying this. Well, it equals, you're subbing in 0 here and 0 here, so you're just going to get 6.1. You don't even have to really show the work for that. It's really fairly obvious, right? When this is 0 and this is 0, these terms become 0. So you're just left with the constant. So f of 0 equals 6.1. This is measured in feet, so this was at a height of 6.1 feet when the ball was launched. And that's what you're finding here. So even though we're not drawing the parabola, I'm not expecting you to draw it, you should have an understanding of what you're finding when you find each piece of this. It all relates back to a parabola. Sometimes people mistakenly assume that this happens halfway where the vertex is, and that's not true because the height of this is over here. Really, if you followed this back, this is where you got that other x-intercept where we rejected it. The negative 2.75 would have been here on the parabola, but it doesn't apply to this problem because in the application, our distances can only be positive. So it's important to understand, it goes back to the shape of the parabola, but we're only using really the positive parts of it, right? We're not going below the axis or to the left of the y-axis. So, hopefully those videos help in determining, maxes and mins for parabolas. We'll do some more examples in the next video where we have to come up with the equations ourselves.